Rob Walters. I'm a product manager at MongoDB on the Atlas Stream Processing team. I've been at Mongo about 8 years or so. Did a lot of variety of roles, and also own the Kafka connector. And about a year and a half ago or so, MongoDB invested in stream processing and moved the Kafka connector over there, and that's kind of how I came to be with it. Apologize for on the bottom of the screen. It's this HDMI cable doesn't like Macs too much, so we made it work. So I just have to share my screen. Some of the things, one thing to note here is we are a publicly traded company, so I'm going to say things that we might do in the future that might not ever come to fruition, so don't hold me accountable. That is basically what all this stuff says. Whatever, just throw that in there. So today I'm going to talk about connecting MongoDB within the Kafka ecosystem. So basically, we're going to review the number of ways to do it. We're also going to talk about Atlas Stream Processing and review the AWS Confluent and MongoDB reference architecture. I have Igor here from AWS, who's going to come up like towards the end of the conversation and just kind of review the reference architecture, which will eventually be in blog form, so people can review that. So just at a show of hands, who uses the Kafka connector today? Just going to do that. Okay, about half of you or so. All right. So what I'm going to talk about with Atlas Stream Processing might be of interest to you because there are some use cases where you can replace that or leverage it in conjunction, which might make your infrastructure management a little bit easier, as you can see some of the capabilities that we have. So I'm going to first off show this diagram, which might be familiar to some. This is sort of taken from the Apache Kafka documentation about ways to connect to a Kafka cluster. And so you might be familiar already with producers and consumers and connectors and things, and also stream processors, which, as you can tell from this conference, there's an awful lot of interest in stream processing. There's an awful lot of vendors getting involved in stream processing, as well as obviously Apache Flink. So when it comes to working with MongoDB, you can write a custom application, so a custom application, a producer, a consumer, and so forth. This is you have a lot of control over it, so it's very intense in terms of like programming requirements, testing it, and publishing that application and maintaining it. So while it's very powerful to do, it's very time intensive, and plus you have to know Java or Python or whatever, pick your language. And so an easier way to interact with MongoDB within the Kafka ecosystem is to use connectors. So the MongoDB connector for Apache Kafka, we as MongoDB acquired the open source a couple of years ago and have been sort of building on it, releasing about once every quarter based off of customer requests and bugs and things like that. And really the way the connector works is it supports both source and sync. When it's used as a source, what it does is it connects to MongoDB and opens up a change stream. So a change stream is like a change data capture capability of MongoDB. So it allows you to get data as it's flowing through the op log. So all of the insert, update, delete statements and so forth are received by you, and here in turn you can write them out to Kafka topic. When it's used as a sync, you can read one or more topics from a Kafka cluster and write them into a MongoDB database. So this is a very basic behavior. It's used by thousands of customers all over the world in a very stable Kafka Connect infrastructure. So this is kind of the way it's done today. There is another option, though, to use to interact with MongoDB with Kafka topics, and I'll talk about that in a moment. So we do have the MongoDB connector for Apache Kafka is open sourced, so you can download it. You can create PR requests if you want an added additional functionality. It also is hosted on Confluent Hub, so this is how you can download it. You can also use the Atlas Source and Sync, which is a hosted offering in Confluent Cloud, which you can go there and use that as well. So now we're talking about stream processing. So we've talked about producers, consumers, using the Kafka connector, and the stream processing landscape obviously is growing, as I mentioned. There are a number of different options. So we have K-Streams, so the Python client library that allows you to work on streaming data, KSQL, which is the original, I believe, SQL base that Confluent supported. And also Spark streaming. So here they're using more of like a micro batch approach to streaming, and of course Flink, which the majority of this conference is about, and a lot of effort and energy is behind it. And MongoDB, about 18 months ago, decided, look, let's make it really easy for MongoDB to work with streaming data. And that's really the genesis of Atlas Stream Processing, is how do we make it easier for our customers to work with MongoDB to leverage the power of the document model and the aggregation framework with streaming data. So if we look at MongoDB's strengths, we have this document model, right? So we can take a data really in any format without the restrictions of creating schemas on it and put it into MongoDB. So a lot of streaming data, although like a lot of folks leverage schema registries and things, they're very hard, but you can pretty much have streaming data that might read temperature, for example, and then maybe the firmware gets upgraded and all of a sudden you have barometric pressure or something in there. So the schemas are kind of different. So we don't want things to break when that kind of data flows through. So MongoDB would be a kind of a great place to put that kind of data, because you can just put in whatever data you want in there. Then if the application understands it or not, that's great. We also have this great language called the MongoDB Query API that you can query this unstructured data. So what if we took that technology and applied it to streaming data sources like Kafka, or like MongoDB change streams, or in the future like other messaging sources? That's kind of what the idea behind Atlas Stream Processing is. So again, this is just an example document here. On the left-hand side, we have an underscore ID, which is our primary key in MongoDB. But if you look at an event and say this is a temperature measurement here, you'll notice that it has a timestamp. So they're very similar. And of course, it's JSON, and lots of people like JSON. So this is kind of where the similarities lie, a lot of similarities here. And event data can get complex. And with our MongoDB aggregation framework, we can easily query this kind of data. When it comes to event data itself, there are three key features of Atlas Stream Processing. It is continuous processing, and we were debating on whether this feature should be called stream processing or continuous query, because that's really what's going on under the covers, is what we're taking data, we're taking our Mongo query language, and we're continuously running a query against it. Because there are some certain use cases that you don't really want to take data, write it to a database, because when you do that, then you have to update the index, and then by the time you query it, a lot of time and resources go by, versus taking the query engine and applying it directly to the streaming data, where you do not have to write it to a database, index it, and do all the other kind of stuff. And that's really where the power of continuous processing comes in. When it comes to continuous validation, this is the ability to actually use what we have. We have something called $validate that can look at the actual document itself and either disregard it or write it to a dead letter queue. So there is some form of control you have in terms of the structure of the document, and I'll show you that in a little bit. As well as continuous merge. So this is the ability to write back to Kafka or to MongoDB. So with stream processing, you do not need an Atlas cluster. So it has pretty much nothing to do with MongoDB itself as far as the cluster goes. It just uses the same MongoDB platform and security model. So if we were looking at a data flow diagram of data as it flows through Atlas Stream Processing, there are streaming sources available. So today, with our first release, we support Apache Kafka. So this is any Kafka wire protocol. So this could be Azure Event Hubs, could be AWS MSK, Confluent Cloud, Red Panda, anything that speaks Kafka wire protocol you can connect to and read or write data to. It also supports Atlas chain streams. So that's what we have today. As this data comes into the stream processor, you can do anything you can do, or almost anything you can do with the MongoDB aggregation framework. So this is like $add fields, $match, all those sorts of things. So as you're building out your stream processing queries, it's the same experience as you have in MongoDB today. And as an output, you can take these results and materialize them back to a Kafka topic or to a MongoDB Atlas database. So what's kind of important to note is when we first start talking about this, some folks think that, well, do I still need Kafka? So this is not a Kafka replacement. So we are not hosting Kafka. We are not like a messaging engine. This literally is just the ability to query against a stream of data. So you'll still need Kafka wherever you host it on there. But it does give you that ability to continuously process, validate, and merge the data. So before I get into the demo, I just kind of want to talk a little bit about how, on the back end, how things work, because it might make the demo a little bit more easier to follow. So in MongoDB Atlas today, you have clusters, which you might have used them, and these are just hosted versions of MongoDB. Well, we have this concept called a Atlas Stream Processing instance. And an instance is kind of like a cluster. It's not the same. But it is something where clients connect to create their stream processors. So today we support AWS in regions, a variety of regions throughout the world. We will eventually support Azure and GCP. So what you do is when you go into the Atlas portal, you say, yep, I want a stream processor instance. You provide a cloud provider in region. And from there, you use a client tool to connect, just like you do on a database today, whether it's Mongo Shell or VS Code, and actually use those tools to configure a stream processor to run. And when a stream processor runs, it runs in perpetuity. So remember I was saying this is a continuous query. You're defining that query that runs in perpetuity. And that's really what's happening with the stream processor instance. And to define which sources and sinks are used, you use a connection registry. So here's where I'm going to define connections to Confluent Cloud, connections to my Atlas database, et cetera. So let's just kind of jump in here. I'm going to actually flip over to the UI just to show you this demo here. I don't know if this is highly visible. It's probably not, so I'm going to increase my resolution. Hopefully that's a little bit better. So if you log into the Atlas portal, you'll see on the left-hand side a number of services. So it's not just the database that MongoDB Atlas has. We do have support for search. We have vector search, triggers, and a bunch of other services available for you. So stream processing is one of them. So if you click on stream processing, you'll see in the beginning there won't be anything here. You'll have to hit create instance. When you hit create instance, you'll see you can choose a provider and region. One kind of very important thing to note is that you are not billed just for creating a stream processor instance. So we're sort of fixing this UI now because a lot of customers think I'm immediately charged whatever 40 cents an hour. That is not the case. So when you supply a provider and a region, you give it a name and you click create. That will basically create the container that you can use to connect to and create stream processors. So I have created one already. It is called stock SPI. If I click configure, you'll notice there are two tabs here, stream processors and connection registry. So connection registry is where all my connections that I want to use in stream processors live. So right now I have pre-configured a bunch of these so I don't have to, you don't have to watch me sit here and copy paste all my credentials. If I click add connection, you'll notice that we just have three things out of the box. First is a sample stream. So this is useful for when you want to play and learn with some of our UI and Mongo Shell and so forth to sort of have sample data that's just constantly flowing through so you can do things like window functions and that sort of thing. You can also connect to your Atlas database. So currently today you're connecting to anything that's in your current Atlas project. So here, for example, I have my demo cluster. And also, there's a drop down here, if you can read it, that says execute as. So we take security very seriously here. And so we enable principles of least privilege here. So when this stream processor is executing and it's either reading or writing data from a MongoDB cluster, you can determine which role or user the context is executed under. So you can give that role least privilege to do its absolute minimum that it needs to do. You can also configure a Kafka connection. So if I go over to Confluent Cloud, this is my current configuration here. So you're providing your Bootstrap servers, your security protocol, and so forth. We do support VPC peering with private link coming in the near future. So once I have these connections set up, I'm actually ready to connect to my stream processing instance and define my stream processor. So I've kind of said a lot. I don't know if I've kind of made anybody lost or have any questions, but up until now, is there any questions about what I've done so far? Yes, sir. Yeah, so the connector itself uses a Kafka Connect, which is a service, part of the Apache ecosystem. So this has absolutely nothing to do with Kafka Connect.
No, I'm talking
yeah.
about the...
So this also uses change stream.
Right.
So when you connect to that's the only similarity between the two. So the connector is basically just the connector, which is part of the Kafka Connect ecosystem, is just a jar, basically a jar file that's used. Yep. Right, yeah. There are some cases, though, where you can directly replace the Kafka connector with stream processing in some cases, like they do overlap in a lot of ways. But there are some cases where you have to stay on Kafka Connect because maybe you have 20 other connectors, like to Oracle and to whatever, and you just, for this one reason, you wouldn't want to rip it out, because you're going to be managing two things. Like SMTs, for example, if you have like lots of SMTs, you still want to stay with Kafka Connect and that sort of thing. So there's a time and place for both of these technologies, but in some use cases, like if you're just moving data, whether it's filtered data or whatever, right, from Kafka to Mongo or vice versa, or whatever, you probably could use stream processor, and from a cost standpoint, it might be better. But you kind of have to do, your own, like due diligence there, and kind of figure that out. We're constantly evolving it, but as far as the technology goes, when it comes to change streams and all that, it's the same thing. When you connect to Mongo, we do open a change stream, and from there you can filter it and those sorts of things. So, cool. So up until now, what I've done is I've created a stream processor instance and I define the connections I want to use. That's pretty much all we've done. So now the next step as a developer, I'm saying, okay, I got my connections defined and now I want to connect to my stream processor instance and I want to start, creating stream processors. So there's a connect button here and that's going to pop open a dialog that looks a lot like the connection dialog to a regular Atlas cluster. It kind of, is basically. And it provides you two options. One is the shell and one is MongoDB for VS Code. So we don't have support yet for Compass. That's, coming soon. We don't have support in the UI, in the Atlas UI to create a stream processor. So that's also, kind of down the road. So if you want to use this today, you got to be, comfortable with, command lines and things like that, which we found a lot of users are. So I'm going to use the shell. So this is Mongo SH or Mongo shell tool. I'm going to use password authentication, so I can just copy this. I'm going to come over here to my command line. I'm going to make this a little bit bigger here. There we go. Hopefully people can see this, or I'll try to make that even bigger. There we go. All right. And if I paste it in here, so this is just me using Mongo shell connecting to, just as I do connecting to a MongoDB cluster. So the experience is the same. It's going to drop me right into here. I can say sp.list connections. So we do have a list of Atlas Stream Processing commands, so one of which is list connections. So here are the 4 sources that I configured on my stream processor instance. So we do have one called sample stream solar. So if I came in here and I predefined, let's see, s equals $source, and I'm going to have connection name, and this is going to be sample stream solar. All right, so I'm defining a variable called s, and I'm just going to say sp.process, s here. So there's a command called .process, and .process really is like a developer tool, because when I create a stream processor, it basically takes the pipeline and it pushes it to the back end and it says, okay, you run that in perpetuity forever. And whatever it does, write to Atlas, write to Kafka, whatever, but it's not going to show me anything on the console. So sp.process is a developer's tool saying, here's the pipeline, just show me everything like in the console where I could see what's going on. So right now I only had a single stage, and that is the sample stream solar. So this is sample data that's coming from our data generator for you to use and play with and create whatever you want. So what I'm going to do here is I'm going to start writing data to my Kafka topic. I'm just going to delete this here. This is my old, just making sure it works, obviously. I have a fictitious stock generator data that randomly picks 5 company names and starts generating a whole bunch of data to it. So if I come over here and look at my Confluent Cloud here, and hopefully I'll have to re-log in again, which I might. I'm just going to show you the kinds of data that's in there, and then we'll use a stream processor to load that. So while that is doing that, perfect. So I have one cluster here, my current cluster, and topics. So I have a stocks topic, and if we look at a sample of the messages here, I realize this is a little hard to see, but I do have a key, and the key is the stock symbol. The value is my sort of fictitious price, company name, and symbol. And I do have some header information in this message. So all of these things, the key, the value, and the header are all accessible from stream processing. So if I want to do something interesting on the header or leverage the key for something, I can do that as well. So I'm going to head back over to my command line. And now I'm starting to write my stream processor. So in the interest of time, I'm just going to copy and paste rather than type. You folks don't want to watch me type lots of things. So here I'm going to make a connection to my Confluent cloud, to my stocks topic, and I'm just processing. So I just want it to show me what is going in the Confluent cloud. And so right now, here's the data. I have an exchange, my company symbol, name, here's a price, and here's the transaction time, and as well as here's some metadata. I have the key and the header information. They're in binary. So if I'm going to use this, I have to sort of convert binary to string, because that's what it's stored in. So to do that, I'm going to add two more things here to my pipeline. I'm going to add an add fields command and a project, because we're taking that binary data and we are converting it. Just for simplicity, I'm going to do that in here. So I'm going to add a field called headers, and I'm going to take that key value pair, and I'm going to basically convert it to a string, a UTF-8 string. So that's kind of what's going on here for the purposes of the demo, to convert it from binary to string. Once I do that, I can come in here and do an SP process again. And this is just to kind of show you integrating like headers and keys and so forth within the message itself for you to manipulate however you want. Whether you want to transform it or leverage that data and do some conditional logic, you can do that as well. So my converted header, which is my transaction currency, was USD on there. So when I talked about continuous validation, so we do have $validate. We do not have like integration with a schema registry or anything like that, but if you wanted to ensure certain things are a certain way, or if you wanted to validate, say, messages only contain a certain value or so forth, you can use $validate. And so one of the options is to, when something goes outside of the configuration, you can discard the message, or you can send it to a dead letter queue. And so you can define a dead letter queue, which is an Atlas cluster collection, to put messages in, or you can just discard it. So for here, I'm saying anything that's not, anything that does not equal New York Stock Exchange, discard it. I also do NASDAQ. They have like little fictitious stocks that go there. So anything for NASDAQ, don't do that. So again, I'm doing sp.process just to kind of show you as I step along. You don't have to use sp.process for this, but just so you can see everything in NASDAQ's flowing through, the New York Stock Exchange stuff just gets discarded. So it's just a way to do some validation. So in terms of other options here, we can do tumbling windows and hopping windows. So here's an example of using a tumbling window that will iterate. It'll take 5-second chunks of data, and it'll group it by the company symbol and do that. So again, I'm going to use SP process so we can see as I build out this to make sure that it's got the right fields and values and so forth. And since my data generator is feverishly inserting data, not in real time, but just like every single like microsecond, it's creating like lots of data for us to kind of look at in a variety of shape. So here I've got my mean, my max, my average, as well as some metadata about the window itself. So the start and end of the window, because I'm using a window function. So now at this point, I'm kind of ready to take this data and merge it somewhere. So we have a $merge command that will take data and insert into a collection or back into Kafka. And so here I'm going to write it to my MongoDB Atlas cluster, my stock data database, and my stock results collection. So when I do that, if I do sp.process, I'll no longer use that. I'm actually going to create a stream processor. So this is where that long-running query will be sent to the backend, and it'll just run in perpetuity when I start it. So that's kind of where the difference between .process and create stream processor. So now if I said like sp.stock, .stats here, it's not running right now, but the metadata is recorded. So from here, you can see this is the pipeline that I created, but the stats are blank because I'm not doing anything with it yet. So if I hit start, now the stream processor itself is running. and it's taking data from Confluent Cloud, it's creating my tumbling window, and it's writing them into Atlas. And I know that because I can hit .stats, or I can look in the UI. If I do .stats, what's interesting is you'll see the status is running, but it's showing me the input message size. It's showing me how many messages are going out, which kind of makes sense because I have 500,000 that came in since I started it, and then 3,000 are going out because I'm doing a tumbling window as I'm averaging and grouping by 5-second increments, which is why there's obviously a lot less messages being written out than written in. So I'm going to flip over here. One thing we also do support is verbose mode here. And what verbose mode allows you to do is see per stage in the pipeline the execution time it takes within that stage in the pipeline. So it all says 0 here because these are relatively very fast operators. But if you were calling out to a REST API operator, for example, or something, you might have a much larger lag in it, and you can actually go through and help debug your pipeline to see kind of where things are taking the longest. And if I go back to my MongoDB cluster here, and we will see the data that's showing up here. So any questions on this demo thus far? There, is that pretty good? Okay.
Just one question, is it the same user, Robert?
That's writing that?
Yeah, the same user as the cluster?
So, yep. So there are two things kind of going on here. So at the Atlas level, so at this UI level, you have to be a project owner or a stream processing project owner in order to create a stream processing instance. So over here, you have to be that level of a role. We are introducing like fine-grained authorization where you don't have to be a project owner or anything like that. You can create like someone else who's a little bit least privileges. That will allow you to define a stream processing instance and all the connection registries, because you don't want just you might not want your developer to know what your Kafka password is or whatever. So the idea is that as an admin, you say, yep, you can use like Confluent Cloud connection name, and you can reference that in your stream processor, but you can't actually know what the credentials are or anything like that. So when we went into configure, say under Atlas source, for example, this execute as tells the stream processor instance which credential should I run under when I execute this. So right now it's set to Atlas admin. That obviously is not really like a production way that I would recommend, but you can create a role like I have like SP test role, for example, and maybe that particular role only has insert privileges on this demo cluster, and that's kind of the way you want to think about setting this up. And an admin sets this up. I mean, unless you're a small enough shop or your developers are admins or you have that they have that kind of freedom. But usually admins, this is their place. Once they define this, they will go into like database access here. And this is Rob, so this is me. I didn't make myself an admin, but I could easily come in here and create a custom role. And that custom role could be just access to that stream processing instance. So down here, you can restrict access to specific clusters or stream processor instances. So you can create that user and says they only have access to like this SPI. So you can definitely create a very granular experience. It just requires a couple clicks and requires that sort of planning as far as the roles go. Does that answer your question? All right, great. So as I showed you here under the demo, hit browse collections, and you'll see that the data is popping up here in the collection, which is the summation of those 5 stocks. Cool. So I'm going to pop back over here to the slides. Cool. All right. So I kind of showed this to you like in the demo. This is just a slide version of it. When we create pipelines and stages, it's really helpful to use variables because you can actually go through and replace the variables and help troubleshoot it versus trying to put everything with brackets on a command line. It gets pretty messy. So a stream processor is just basically a pipeline of stages. You can use a lot of the existing aggregation framework language like $add to set, $merge, $exists, those sorts of things. We did add some new stages. So you saw $merge had some unique syntax. We have $validate, which is also new to Atlas Stream Processing, and $convert and some other stuff that we now support. And as I showed you, .process is definitely the way to go as far as developing your stream processing queries. I showed you start and stop. So this is how you would start and stop a stream processor. and some of the statistics. So these are all things I did show in your demo, but I kind of left them on here to so you can kind of see it for people who use this deck later or can watch them. One of the things I did show you is headers and keys. So we do have the ability to configure the config properties of Kafka. So if you want to provide like your group ID and those sorts of things, you can do it through config. We also can configure the time field. So if you need to convert between epoch time and ISO dates and things like that, you can do that from $source. So we're continually adding additional capabilities to config. So today it's a little light in terms of the number of config options, but we will be adding more as the time goes on. You also see allowed lateness. So we do mitigate the fact that data can come in late. So you can specify, seconds or however long you want as far as the allowed lateness goes, and that's the time delay it'll take before processing the data itself. There's also window functions. So I showed you tumbling window. We have hopping windows, tumbling windows. We also have other windows that are in the queue that you can use for your analytic kind of data. Let's see if I manage everything else here. When it comes to validation, I did show you some of this, but this is a little bit more complicated one, complex in terms of being able to do logic based off of the data. So here we have a validator. It says, well, if it's not equal to the pace car of this race car, then apply this JSON schema to it. So there's things you can do that get pretty involved. And of course, the validation action here is to write to the DLQ as opposed to discarding, which was my example. So at this conference, we talked a lot about Flink. Flink is obviously the gold standard for streaming. And these two technologies can work together. So obviously, I'm not saying that Atlas Stream Processing can replace Flink. It's not even, we're not doing that. We're making streaming a great experience for MongoDB. We do have a customer use case that I had to trim a lot of this back, so I didn't disclose the customer or the exact use case or whatever. But at a very, very, very high level, their use cases are using Flink for some of the advanced capabilities it has to do complex event processing and writing their data to MongoDB. From there, they're using Atlas Stream Processing. It's a little bit more lightweight. They're just listening for deletes that come on that database, and then they are processing those deletes and inserting them into a different database. And then in that different database, they are listening for insert events and pushing it back to Kafka. So some more of these lightweight use cases, you can probably just use the native tool that's part of Atlas Stream Processing, which is part of Atlas. So that's kind of what we are seeing as far as customer use cases for these two technologies. And we do have Igor here, who's a partner, that I'm going to bring him up just for a few minutes to talk about the reference architecture that we have.
Awesome. Thank you. Thank you, Rob. Thank you for inviting me. So I'm Igor Alexiev. I'm a partner solutions architect at AWS. And I just want to quickly talk about this reference architecture we created. You can tell the difference between contrived architecture and real architecture because we've used a lot of components here. Before I start, just a quick show of hands. Who is on AWS here? Who is on Azure? Who is on GCP? Okay, so I'll introduce some of the services. So we're going to start left to right, and I'm going to just zoom in on the slide. So in this architecture, the domain is reviews that customers are submitting, and they have some text, and we have products that they are reviewing. So we have reviews coming from some sources. We worked with Weifang there on the left-hand side of where we created this Flink application that joins the reviews and user accounts and product reviews and user accounts to see if we are trying to catch review bombing when somebody tries to submit fake reviews. So first line of defense is the Flink, where it will connect, that will join them and just count how many reviews a particular user submitting within a certain window. And if that's if it's too many, then it's a review bombing, and we kind of flag it. And then on the right-hand side, that's actually where I worked. We have two more ways to catch the reviews that are we think are fraudulent. So first we're using, actually, is there a laser here? Yeah, I think there is. That doesn't, yeah. So first way, we try to come up with the semantic score, what we call semantic score. So basically, this lambda function is configured to have a trigger. When data arrives on this topic, lambda function is triggered. And what the lambda function does, lambda converts the text of the review into embeddings. Who knows what embeddings are? Okay, embeddings is just a numeric representation of a text which captures semantic information. So similar texts will have similar vectors. And think like, vectors, similarities like distance, Euclidean distance, like, or cosine with like direction. Anyway, two vectors, similar. That's all you need to know. So first we use Lambda to convert the text into the vector using Amazon Bedrock. That's our serverless generative AI service. You can just call a model, give it text, it will give you vectors back. And then we use this vector to search in MongoDB Atlas and see how many reviews are coming with similar reviews are coming back. And in this particular case, we use the simple function. If it's a count, if it's more than 5, it's garbage. If it's less than 5, it's just some gradient of 4, 3, 2, 1, on the quality. And we use a cutoff to similarity because every search comes back with a score like 0.9 or 0.8, like in 1 meaning very similar or identical, 0 meaning completely different. So we just use a random cutoff. And so that information with the similarity score is then enriched, meaning updated onto the review as an extra field, and we store it in a topic. And that topic, that enriched topic, is then, from here, it's going to be stored into MongoDB Atlas using stream processors that Robert was just describing. And I was concerned when I was created the stream processor that the billing starts moment you configure. So I was always like,
yes.
I want to delete this.
Common confusion.
Yeah, now I know that. It's only when you start and stop, right?
Yes.
Yes, awesome. All right, so this is basically we've submitted enriched review into MongoDB Atlas. Then on the left-hand side, there is another Lambda function here configured similar. There's a trigger here that's configured that triggers the Lambda. And this trigger, what we are doing is we're using, again, Amazon Bedrock. We're using Claude 3, one of the models. It's Anthropic model. I think it was Sonnet. And we retrieve the 5 most recent reviews of that product, and we create a summary. So the summary basically updates itself. We summarize those reviews, so you have a summary that is very current. So as the reviews are changing, you have a most recent summary kind of meshed together. And here we issue a JSON object with basically product ID and this updated summary. And again, we use the stream processor, we store it in topic, and we use stream processor to merge. And you call them pipelines, right?
Yep.
Our pipeline is very simple. It's a Kafka connector plus a merge operator in both cases. So just in one case, it's a product product document, and in the second case, it's the review. That's pretty much the architecture. If you want to stop by if you want to seek code, stop by the MongoDB booth. Yep. Otherwise,
so this is a work in progress, basically, and so we will have a blog post on this, right?
Yes.
In terms of there'll be a lot of stuff to kind of dig in and learn more. We just kind of hot off the press, so to speak. So we just kind of wanted to say, hey, this is coming. So if you're using AWS and you're using like Lambda and these kinds of functions, you'll be able to reference it.
All right. Thank you, Robert.
All right. Thanks, Igor. So basically, there's some key takeaways here. So we do have native stream processing capabilities within Atlas. It extends the aggregation framework with specific options, as well as is easy to use, cost effective, all the kind of marketing stuff here. But hopefully today you learned a little bit about stream processing, kind of where we're going with it, kind of the capabilities are. It is not Kafka, so we are not a message store. It's the very first thing people think is we're replacing Kafka. We are not replacing Kafka. It doesn't require Kafka Connect at all, so you do not need Kafka Connect or deploy distributed mode, all the other kind of stuff. All that stuff kind of goes away. Under the covers, we're just a Kafka consumer, just like any other sort of application on the back end. So that might simplify some things. So for simple use cases, this might be an interesting option for you. Obviously, for the more complex ones and things like that, when you're integrating, there's Flink, there's Kafka connectors, and those sorts of things to use. So thank you, everyone, for hanging out and letting me talk to you about stream processing. Well, thanks.